In this video, we are going to talk about how to solve simple algebraic equations. But first, we need to talk about what exactly solving an equation means in this case. Well, when we are solving an algebraic equation, we are solving for a value of x that makes the equation true. And not necessarily a value of x, but really just the value of what your variable is in that equation. So let's take a look at this problem. 7 plus x equals 9. So I know I haven't told you how to solve this yet, but we could just take a look at this and realize that if x, and I'll write this here, if x was equal to 2, if x were equal to 2, well, this equation would be true, right? 7 plus 2 equals 9. So hey, x x is equal to 2 is a solution to this equation. So here I've listed out some problems to help us practice solving equations. And we could just look at all of these to figure them out with our brains, but to solve equations like this, we are going to isolate the variable, which in this case is x. And what that means is we're going to move all of the constants to one side, which if we do that will just give us the value of x equaling some constant. So in this first problem, what we can do to isolate x is actually subtract 4. Subtract 4. But when we do this, we have to subtract 4 from both sides, and I'll draw a line here. We have to subtract 4 from both sides to keep the equation equal. So to do that, on this side, we can cancel out these 4's, because whatever x is, if we are adding 4 and then subtracting 4, well, that's just going to give us the value of x, right? So we can do that. Cancel this 4 and this negative 4. And then 11 minus 4 is going to be 7. So now we were just left with x being equal to 7, and I'll rewrite this up here. X is equal to 7. And you'll notice we have isolated x, which gives us our answer that x is 7. And we could fact check this by replacing x with 7 in this equation up here to guarantee that 7 plus 4 does in fact equal 11. So now let's solve for the value of x in these other two equations. And remember, what we want to do is isolate x to do so. So in this first problem, to get x by itself, we need to cancel out this negative 5, which we can do by adding 5. Because whatever the value of x is here, if we're subtracting 5 and then adding 5, well, that's just going to be x, right? But remember, to keep the equation balanced, what we need to do is add 5 to both sides, So if we do this, we get that negative 5 and 5, well, that equals 0, and x plus 0 is just x. And then negative 6 plus 5 is going to be negative 1. So here our answer is x is equal to negative 1. And I encourage you to go back into this equation and plug in x minus 1, which would give you negative 1 minus 5, which is indeed negative 6. And then for this problem, we notice here we don't have anything adding or subtracting from x. Instead, we have a 3 times x is equal to 18. So what we're going to do to cancel out this constant multiplying x is actually divide by 3, right? Because whatever 3 times x is, if we divide this by 3, we're just going to end up with x. So let's do that. If we divide 3x by 3, and then remember we have to divide the other side by 3, this 3 multiplying and this 3 dividing is going to cancel out. And then this 18 over 3 here is going to turn into 6. So our answer for this problem is x is equal to 6. And we have solved all 3 of these equations. And hopefully you realize that this is not too bad. Now let's solve this two-step equation for the value of x. And to do this, similarly to the one-step equations, we just need to isolate x. And the general rule to do this is to do subtraction and addition first, and then do multiplication or division. So first, let's go ahead and draw a line here, because we're going to want to apply what we do on one side to the other, and this will just help keep things in order. So to cancel out this minus 4 here, we're going to add 4 to both sides. And once again, I encourage you to understand intuitively that we're not necessarily canceling out. What we're doing is realizing that if we subtract this by 4 and then add 4, we're just going to be adding 0, which does not change the value of x, so we just kind of leave this out. And remember, we have to add 4 to both sides. So 11 plus 4 is going to be 15. And I'll write this here. 15 is equal to 3x. 3x. And then what we want to do now is divide both sides by 3, because that will isolate x. So we have 3x divided by 3 and then 15 divided by 3. Well, these 3's are going to cancel out because if we multiply something by 3 and divide it by 3, this is just going to be x, right? So we can cancel these out. And then 15 divided by 3 is just 5. So our answer here is x is equal to 5. And this is our answer. Now let's do one more problem of solving for the value of x in the algebraic equations. So in this example, we have x being divided by 7 plus 12 is equal to 40. And what we're going to do first is subtract this 12 to isolate x over 7. So let's go ahead and do that. So we can subtract 12 from both sides to keep the equation balanced. And then plus 12 minus 12 is just going to be 0, which we could cancel out. And then 40 minus 12 is going to give us 28. 28 is equal to x over 7. All right, that's a little bit more centered. Is equal to x over 7. And now to isolate x from here, what we're actually going to do is multiply both sides by 7, because whatever we have x divided by 7, well, if we multiply that by 7, this is just going to cancel out. So we can go ahead and do that. We can cancel out the 7's, and then 28 times 7 is going to give us 196. 196 is equal to x. So here we have solved this problem, and I'll write it here. The value of x in x over 7 plus 12 is equal to 40 is 196, and we are done.